Hello everyone, welcome to our new CA tutorial. And in this tutorial, we're going to analyze programmable machine, particularly question number 2, part B. And this is a homework questions, and these questions are going to be in our midterm exam. So before watching this tutorial, please I ask you to watch a tutorial where we analyzed part A, because this is a simpler, but this is a fundamental, and this should be understood by you before switching to part B, because part B is a little bit sophisticated, complicated, okay? So you have to know fundamentals before moving to more complicated stuff. In part B, you have this programmable machine, and your objective is to find n to the power k. For example, if n is 2 and k is 3, you have to find 2 to the power 3. And you accomplish this by stating states. For example, here, as you can see, we have 4 states, and our objective is to use registers in order to write our program or implement our algorithm in the right program. And we have to also identify what state comes next after a particular state when we give a particular input. For example, if you give 0 input to 0 state, first state, you have to identify, you have to write what state comes next, okay? For this, you have to have algorithm. So if you want to know more about states and filling these tables, you have to fill these tables based on states, okay? You have to watch part A, because I'm not going to focus on this more. What I'm going to focus is mainly on algorithm, because we have to firstly fill this state, okay? And we can fill this based on algorithm, so we need algorithm, okay? So let's firstly analyze this algorithm. So this is very simple. We have two inputs, n and k. We have to give output n to the power k. So what I'm doing is I'm looping inside the loop until k is not equal to k, until k is equal to 0, okay? So when k is equal to 0, I'm going to terminate the loop. So let's consider this example. N is 4 and k is 3. We're going to return 4 to the power 3. Initially, our r is 1, our result. So when k is 3, I multiplied 1 to the 4 because r is 1. So I'm doing what? I'm doing this operation. So, and r is new r1 is this one, is 4 now. And then I'm going to decrement k, and k becomes 2. When k is 2, it's not equal to 0. We're checking this, okay? Before multiplying r to the n and the updating value of r, we're checking this condition. K is not equal to 0. Okay, let's write k is not equal to 0. So we're multiplying r to the n again. Our r was 4, updated 4 to the 4, 16. And again, decrement k, so k becomes 1. It's not equal to 0, so we're multiplying 16 because the value of r is 16 now. To the 4, it becomes 64. And then the decrement k, and k becomes 0, and this equals to 0. So that's why I'm not going to loop again. I'm going to terminate. So loop is terminated. Our result is r, which is 64. Okay, but let's look at the given values of registers. So I've written here, we have n in r0, we have r1, and it has value k. We have -1 in r2 and 1 in r3. Actually, this r3 is our r, okay, in our algorithm, because it has 1. We're going to store the result in r3. But as you can see, we don't have the value, or let's say the register which contains the value 0. But we need 0 in order to compare it with k, so that our algorithm can terminate, yeah? This is a condition for termination, okay? But we don't have 0. So, we have k in r1, this is r1 register, but we don't have 0, but we have -1, and this is in, I guess, in r2 register. So this has -1, this has k. So thus, as we don't have 0, we should compare k with k minus 1. Okay, we should compare k with k minus 1, and yeah, based on this condition, we have to change this our algorithm, because if you simply kind of change this condition and remove this 0 and put -1, our result will not be correct. So let me explain it, or let me kind of continue this. For example, let's imagine that we have here -1. Okay, and now when k is 0, when k equals to okay, let me change this color. Okay, when k equals to 0, we're not going to terminate, right? Okay, we're not going to terminate because we're going to continue, and what I'm going to do is again to multiply r to the n. Our r was 64. I'm multiplying 64 to the 4, and my result is 256. And then I'm going to decrement k, and in this case 0 minus 1, because k is 0, -1 is going to be -1, and then this condition becomes true, and then k equals to -1, and now here I'm going to terminate. And I guess you see the point, right? Because what our input was, what, 4. Let me change this color now. Our input was what was 4. I mean, and 4, k is 3, so our result should have been 64, but we are getting 256, which is 2 to the power 2. And now I see that we are getting always, for example, this is n, this is k, and this is what, n, and this is k plus 1. You see, if we compare our k with -1, we always get k plus 1. So this, before entering to the loop, before coming here, let me delete this unnecessary stuff here, because you know this is condition for termination. You already know. So let me quickly delete it. So before coming here, we have to kind of decrement k beforehand. So that when we come to the result at the end, although we are kind of checking k minus 1, finally we won't have the value k plus 1. We will have n to the power k, okay? I mean, to the 3, because if you give 3 to the k, you won't have, for example, some value to the power 4. You will have exactly what you want. For example, not for example, but let's add this condition here. I am adding this condition. Let me choose this color. Before entering to the loop, I am decrementing k's value beforehand, and then let me delete everything here. Sorry. So let me delete everything here. I'm going to I'm going to write everything before from the beginning. Okay, I mean, I'm going to show an example so that you can be sure that this algorithm is now correct, although we are checking k with -1. So again, I'm going to do this algorithm. I mean not this algorithm, but this input. I'm going to check this input. So before entering to the loop, k was 3, now k becomes 3 minus 1, 2, okay? Then loop, we are inside the loop. So 2 is not equal to the 0, I mean this is k, this is r multiplied n, and r1. So that's why we multiplied 1 to the 4, and our new r is 4. Then we're going to decrement k, okay? We are here. We have done this one, and we are here. We decremented k, and we're checking. I mean, we're again inside the loop because 1 is not equal. Sorry. We're not I mean comparing with 0 but with -1. So now we compare our, I mean k with -1, and this is not equal to -1. I mean 1 is not equal to -1. Okay, so again we multiply r to the n. Our r is 4 and it's always 4, so new r is 16. So again we're going to decrement it right here, so k is now 0, which is not equal to -1. So thus we are multiplying 16, which is r to the 4, and the result is 64. And then we are again decrementing k, which was 0, now it's -1, and again -1 is equal to -1. This condition is met, so thus we are going to terminate, right? We're going to terminate, and our final value is 64. Okay, so now I'm coming here. As you can see, here in the first state, as I see, we are doing what? We are decrementing r1, and r1, as you know, is k. So in our 0, 0 state, what we are doing is k minus 1. Okay, so as you know, in the next step, what should we do? In the next step, we have to enter to the loop, right? So in 0, 1 state, we're again entering k, I mean, we're doing k minus 1, okay? So our k is r1, okay? Our k is r1, so let me write it in this fashion. r1 minus r1. So then you know this the z, we have here z, okay? So we have here z, so it checks, I mean the z value, it checks two given registers value. So whenever we pass r1 and -1, as you know, r1 has register, r1 has value k, and r2 has -1. Whenever we pass this value before entering into the loop, this is our condition state, okay? This is our condition state as this one, okay? This is our condition state. So it checks two values, and if z is 0, what does it mean? If z is 0, that means k is not equal to -1, so we should continue in our loop, okay? Let me delete this one. We should continue loop, okay? Let's say loop. But when z is 1, that means k equals to -1, so we have to do what? Terminate. So with this fashion, I'm coming here. So see, this is initial state, okay? And now I'm going to the next state, and it doesn't matter, the value of z doesn't matter. If the value of z doesn't matter, you put just this x, okay? But when the value of z is 0, I am going to this, I'm going to here. If value is 0, this 0 means z is 0, that means r1 doesn't equal to -1, that means k doesn't equal to -1. So I'm going here, I'm going to kind of multiply this. This is r, okay? This is r, this is n, and I'm multiplying kind of n to the r and putting this value to the r, as I've explained it in the algorithm, okay? So but if the value of r1 and the value of -1 are equal, that means if k equals to -1, so I'm going to terminate, okay? I'm not going to enter to the loop. This is loop condition, I mean this main loop operation, multiplying r to the n. I'm not coming here if value of z, okay? This is z, I mean if value of z, as I explained here, this is value of z, this is condition state, this is condition for loop termination, okay? Based on this condition, we're going to decide whether we're going to terminate or not, okay? So if the value of z is 1, so I'm coming this final state, no operations, that means done state, okay? Done state. Okay, I'm now here. So I'm now here in this 1, 0 state. I'm multiplying r0 to r3 and putting the value in r3, and then I am coming back to the loop. I mean I'm coming back here, right? Doesn't matter whether z is 1 and 0, because you know, after multiplication, let me show it here. After this condition, after this state, you're coming again here, right? So let's say this is one, this is one, this is two, and this is condition is three. Okay, so here is also right like this. Let me choose a different color. This is one, this is first operation, and then you're coming here, you're coming here this state, because this state is what? This is a state where we decrement the k. Okay, where not where, but here we decrement the k. Here we minus 1k. Okay, this minus means decrement. So this is second operation as I written here. Okay, this is the second one, and then you have to do what? Check whether k equals to minus 1 or not. So this is what? This is here. This is this one. This one. Okay, you're actually this one. You're kind of checking here, but again, based on this z, you're deciding whether, for example, whether again to go inside here if it's zero. If this condition is zero, if z is zero, you're again coming here, which is what? Let me choose this red color, which is what? You're again coming here. You're again coming here. You're again coming to operation 1, because you're again coming to operation 1. Or if the value of z is 1, if k equals to minus 1, you are coming here to return state, to down state, which is what? Here. If the value of z is 1, you're coming here to down state. So I hope it was pretty understandable for you, and yeah, this is basically done. We are done with this filling out the state. Okay, this is very important, because filling out these tables are really easy, because you have to kind of choose a select and b select, and for example in state, I'm only considering this one, okay, because we have not so many time. So let me choose this color. Let me delete this, and I'm going to consider this one. So for more to know about filling the tables, please watch tutorial part A. Again, I'm going to show this one for you. So in state 0, we are choosing what? R1 and minus 1, because what we're doing actually is, we're not choosing 1, please don't be confused. We're doing what? R1 plus minus 1. This minus 1 is R2, okay? So that's why we're choosing R1 and R2. Here in A select, you choose R1, this one, and in B select, you choose this R2, okay? So in binary, A select, so A select is going to be 0, 1, because as I've told you, A select is R1 and B select is R2, right? We have three registers, so 3 digits, 3 is represented in binary with 2 bits. So R1, this is 1, and 1 is represented with 0, 1, 2 is represented with 1, 0. So I'm writing here 1, 0. This doesn't matter, this has this condition, but doesn't matter whether z 0 or not, 1 or not, we have the same selections, okay? So what about this op select? Op select is operation select, and what we are doing is we're doing this plus operation. We're doing what? R1 plus R2. R2 is R minus 1, so this finally we have this one. So actually we are doing this one, okay? So this is what? This is at index 0. This is 1, 2, 3, okay? So 0 is represented in binary 0, 0 in 2 bits. So this I'm writing here 0, 0 and 0, 0. So in W select, you choose registers. You choose a register where you're going to store the value. So we are storing the value here in R1. In R1 is represented, as I told you, register numbers is 0, 1 and 0, 1, and is 1 bit register. You either 1 bit selector, it's either 0 or 1. It is 1 if you do operation and store the value inside the register. So this is 1 because we are storing the value in R1. Okay, and what's the next select? This is next, not next select, but what's the next state? Doesn't matter whether z is 0 or 1, it is this one, 0 1. So in this fashion you'll fill these tables too. So if you have any questions, please just ask in the comments or ask them in our forum. The link to our website is going to be given in the description. So see you soon.